So let's take a look at some of the characteristics that data warehouses have. And to understand data warehouses, let's also look at the context of a production database. So a production database is often called online transaction processing. Online transaction processing databases are your day-to-day databases that you use for particular reasons, such as completing transactions or doing recording events that happen in the database from a day-to-day standpoint. Also, we want to look at this from how a production database works. So we have a limited number of repetitive transactions. So usually these are just one-off transactions that happen and then they're not repeated over and over again. The transaction type might be repeated over and over again, but the actual transaction is not repeated that often. So we also have each transaction typically affects only a few records at a time because you're inserting, let's say a customer makes a sale. So you're inserting a sale into the database and that's it. You affect maybe that one customer and just a few records surrounding that sale, but that's about all. Usually the online transaction processing database is relational or object relational in terms of the model that it's using, and the data is normalized so that you reduce redundancy. You don't want a lot of data being repeated in the database from that standpoint, because again, if you affect something in a small way in one place, you don't want to have to go to another 5 places to also affect that same data. So the normalization allows you to reduce the redundancy so that you don't have to repeat that process on different data across the system. On the other hand, a data warehouse online analytical processing, the data comes from an operational database like we're talking about. The online transaction processing database produces the data that you would move into an online analytical processing database. It may integrate data from several other sources, so I've already mentioned this in the previous video, but all the data that you need for a data warehouse might not be in a single location, so you might have to gather it from multiple locations and multiple different types of data sources. And online analytical processing uses what is known as a dimensional model instead of a relational model. Although in most cases a relational database is where you store it, but the idea is to make it a dimensional model, which we'll talk about in this series of videos, so you can see what that looks like. The data may be highly summarized and repeated. So instead of normalized data, this is often denormalized data so that you have repeated data stored there. And the idea is that you want to be able to access that data as quickly as you can. And denormalized data in this case is a great way to do that. So again, looking at these differences, the online transaction processing typically deals with a smaller amount of data at a given time. So they're usually in the terabyte range, where that's 1 trillion bytes. But updates occur frequently. Something is always hitting the database. Think about during registration times for classes. Every individual student is going and registering for several classes, and those updates are occurring commonly during that time period. So they have to be responsive to a large amount of transactions that occur at a given point in time, and you also need to be able to query that data in real time so that you can see what's happening and what's going on in the database. You also need to ensure that data that is manipulated in the database is consistent across insert, update, and delete operations. But OLAP, on the other hand, the data warehouse contains a large amount of information and data. Usually data warehouses become petabyte size because they have lots and lots and lots of information that's repeated over time, and that's a quadrillion byte range, and it's not far away from the exabyte, quintillion byte data warehouse sizes. Updates are infrequent and they're done periodically. So typically what happens with an OLAP database is you connect to your data sources and you get a data dump. And once it's there, it stays there and there's nothing else to do. Queries are often complex in OLAP databases. So there's a lot of grouping, there's a lot of aggregation that happens. So you design your data warehouse so that it can handle that type of query. So in particular, some characteristics of the data warehouse. I already mentioned that it's a dimensional model, so we have a multi-dimensional conceptual view rather than just the simple connections between OLTP, online transaction processing databases, where you have foreign keys that connect everything together. And we'll see what this multi-dimensional conceptual view looks like in a later video. Generic dimensionality. What we want to do is make sure that our dimensions that we're connecting to are as generic as possible so that we can access things through those dimensions very easily. Unlimited dimensions and aggregation levels. So we might want to drill down to a particular year, but in that year we might want to drill down into a month. And in the month, we might want to drill down into a day. So there are large numbers of aggregation levels that this allows us to do with data warehousing. Unrestricted cross-dimensional operations. So we want to be able to analyze things across dimensions because that might give us insights into the data that we never had before. Dynamic sparse matrix handling, client-server architecture, multi-user support, accessibility, transparency, intuitive data manipulation, consistent reporting, performance, and flexible reporting. So all of these things are characteristics that allow us to use data warehouses in the most efficient way possible. Client-server architecture simply means that we don't have to have the data warehouse on our machine. We can connect to it through a network, and it's highly accessible because of that. And also because of that, we have to have multi-user support so that several people can use it at the same time. The other things here, transparency, intuitive data manipulation, these are talking about ways that ensure that everybody understands what's happening in the system itself and are able to very quickly understand what data they're looking at and able to produce in a report, for example. And then the reporting should be consistent in terms of performance, and the reason that you would denormalize data is you want to limit the number of joins that you do, because the number of joins can decrease the performance quite a bit. So here is kind of an example of how things work in a data warehouse architecture. So on the left side you see we have three data sources depicted. Two of them happen to be databases, the cylinders that you see there, and the third is probably a file from somewhere. So you have a process called ETL that moves things from those data sources. It extracts them from those data sources. It reformats, cleans, enriches, and refreshes those to transform them into the format that we need to load them, ETL, extract, transform, load, to load them into the database management system and into the data warehouse that we have. So in the center, we see that we have a data warehouse that has raw data, summarized data, and metadata, and then it connects to 3 data marts. Then the support for the data warehouse can feed into a decision support system, an OLAP system, a data mining system, and so forth. And then that cycle continues because we might actually be able to inform our ETL process of tweaks to the process or additional data that we might need. So importing that data, again, it's taken from various data sources, multiple operational databases, independent flat files, environmental data, things that you scrape from the internet. Those all might be inputs into our ETL process. So ETL accesses the data stores, it transforms and integrates that data, and then loads those results into our new system. It's extracted using back-end system tools that accommodate differences among all of these disparate heterogeneous sources. It reformats those sources into something that's consistent, and then it checks for integrity and validity, meaning that you have to ensure that the data is clean, because if it's not, it would mess up the data analytics part of your data warehouse. So putting the data model for the warehouse and then loading into that data model is all part of the ETL process. The DBMS in that diagram that we just showed is the database management system that has the system catalog storing the metadata and other standard database system components that allow you to interact with the database itself. And then data marts are segments of the data that are organized into subsets that allow us to focus on particular subject areas. So we might have data marts that are focused on only the finance system, or only the human resources system, or only the manufacturing parts system, or something like that. The output of the data mart is a database that actually, the data warehouse. The output of the data warehouse is a system that supports OLAP queries. It supports information provided to decision support systems. It provides data for data mining tools. And then that knowledge can then be fed back and also used as a data source itself, as I just said. So there's a lot to a data warehouse architecture. And in the next video, we're going to dig a little deeper into the extract, transform, load process.